So good evening, all. Listen here.
Resource person.
I would like to welcome you all for this 6 days online ATAL FDP on this topic, technological advancement in manufacturing and industry 4.0. It is immense pleasure to invite our management and our expected principal sir, Dr. S. Madagan sir, for his continuous supporting to conduct this program. I would like to welcome our expected HOD, Dr.G.Mahesh sir, for constantly providing support to conduct this FDP. Also, are delighted to welcome all the external participants for this FDP and for extending their support. Once again, I welcome you all for this 6 days online FDP event. I request our expected principal sir to address the gathering.
Good evening. Good evening to all the respected dignitaries, esteemed resource persons, faculty members, and dear participants. It is an immense honor and a privilege for me to address you at the inaugural session of this 6-day online faculty development program on the topic technological advancement in manufacturing and industry 4.0, which is being sponsored by ATAL AICTE. I warmly welcome all of you to this program, and I express my sincere gratitude to AICTE for their continued support in enhancing the professional development of faculty members and researchers across the nation. In today's rapidly evolving technological landscape, the field of manufacturing and industrial practices is undergoing a remarkable transformation. The convergence of emerging technologies such as the Internet of Things, artificial intelligence, robotics, and big data has given rise to what we call Industry 4.0. As educators, it is essential that we remain updated of this technological advancement to not only impart knowledge, but also to empower our students to become pioneers in the upcoming industrial revolution. This FPP aims to provide a comprehensive understanding of the core concept, and along with the various technological advancements in manufacturing that have been revolutionizing industries globally. Over the next 6 days, we will have the opportunity to hear from the leading experts and practitioners in the field who will shed light on crucial topics such as smart manufacturing, automation, digital twins, data-driven decision-making, and the integration of artificial intelligence into manufacturing systems. Manufacturing has always been the backbone of industrialization, driving economic growth and providing employment across the globe. However, traditional manufacturing systems, which were heavily reliant on manual labor and rudimentary technology, have become increasingly inefficient in meeting the demands of modern industries. In today's highly competitive and rapidly changing global economy, manufacturers must be able to provide high-quality products in shorter cycles with reduced cost and enhanced flexibility. This demand for increased efficiency, coupled with the pressure to achieve sustainability and maintain high product quality, has created an urgent need for technological advancement in the manufacturing sector. The advent of Industry 4.0, which focuses on the digitalization and automation of industrial processes, is ushering in the new era of manufacturing practices where machines communicate with each other, where processes are optimized in real time, and where data plays a central role in decision making. Technological advancement in manufacturing are not just about improving production process. They are also about creating new avenues for innovation. So, Industry 4.0 promises to drive advancement in smart factories, predictive maintenance, supply chain management, energy efficiency, and product personalization. These innovations will undoubtedly shape the future of manufacturing sector and redefine the role of humans in the new industrial era. The term Industry 4.0 was first introduced in Germany in 2011 as part of country's strategy to promote the digitalization of manufacturing industries. In its core, Industry 4.0 integrates several key technologies that enable seamless communication between machines, system, and the people. These technologies include Internet of Things, that is, IoT connects physical objects, machines, and devices to the Internet, allowing them to communicate with one another and exchange data in real time. In a manufacturing setting, IoT can monitor machine performance, track inventory, and optimize production schedules, leading to enhanced productivity and reduced downtime. Next one is artificial intelligence and machine learning. AI and machine learning algorithms enable systems to analyze vast amounts of data, make intelligent decisions, and even predict future outcomes. In manufacturing, AI-driven systems can optimize production schedules, direct quality issues, and predict when machines need maintenance, significantly improving operational efficiency. The next one is big data analytics. The integration of big data analytics allows manufacturers to process vast amount of data collected from the machines, sensors, and other sources. By analyzing this data, manufacturers can gain valuable insights into production efficiency, customer preferences, and market trends, allowing them to make data-driven decisions that enhance performance and competitiveness. Next one is robotics and automation. Robotics plays a crucial role in modern manufacturing, improving precision, reducing human error, and increasing the production speed. Cooperative robots, cobots, work alongside human operators to perform tasks such as assembly, inspection, and packaging, leading to a more flexible and efficient workforce. Next one is 3D printing. Additive manufacturing enables the criteria of complex parts directly from digital decisions, offering the potential for rapid prototyping, reduced material waste, and customized products. This technology is particularly useful for producing small batches of products with high precision and low cost. Next one is cyber physical systems. These systems integrate physical processes with computational processes. In manufacturing, cyber physical systems can monitor production in real time, predict potential issues, and initiate corrective actions without human intervention, ensuring that production runs smoothly and efficiently. The last one is cloud computing and edge computing. Cloud computing provides manufacturers with scalable computing resources, enabling them to store and analyze vast amount of data without the need for on-premises infrastructure. Edge computing brings data processing closer to the source of data generation. That means sensors or machines, allowing for faster decision making and reduced latency. Together, these technologies form the foundation of Industry 4.0, allowing manufacturers to achieve unprecedented levels of automation, efficiency, and customization. As we move forward, we are witnessing a paradigm shift in how industries operate and interact with consumers, paving the way for smarter, more sustainable manufacturing practices. As educators, we play a crucial role in shaping the future of manufacturing by equipping our students with the knowledge and the skills required to thrive in this rapidly evolving landscape. The role of faculty members has become more important than ever before, as we are tasked with not only teaching the fundamentals of engineering and manufacturing, but also preparing our students to navigate the complexities of Industry 4.0. This FDP is designed to help you as faculty members enhance your understanding of these technologies and their applications in manufacturing. Over the course of next 6 days, we will cover the variety of topics that will enable you to integrate the latest technological advancement into your curriculum and help your students develop the skills required to excel in the world of Industry 4.0. Additionally, this FDP will provide you with insights into real-world challenges and opportunities that arise from the adoption of these technologies. By understanding the practical implications of Industry 4.0, you will be better equipped to guide your students through their academic and professional journeys, ensuring that they are well prepared to meet the demands of the future workforce. The success of this program depends on the active participation of all involved. We are fortunate to have renowned experts and practitioners from academia and industry joining us as resource persons for this FDP. Their diverse perspectives and wealth of experience will offer valuable insights into the latest trends in manufacturing. I encourage all the participants to actively engage with the sessions, ask questions, and exchange ideas with the experts and fellow participants. Collaboration and networking are essential components of professional growth, and this program provides an excellent platform to build lasting connections with peers and experts in the field. I would like to repeat, the Industry 4.0 is not just a slogan, but a paradigm shift that is transforming the manufacturing landscape. The technological advancement we are witness today are revolutionizing the way industries operate, produce, and interact with consumers. As educators, it is our responsibility to keep pace with these changes and prepare our students for the future by equipping them with the knowledge and skills required to thrive in this new industry era. I extend my heartfelt thanks to ATAL AICTE for sponsoring this FDP, and I assure you that this program will be a valuable and enriching experience for all of us. Let us make the most of this opportunity to learn, collaborate, and build a future-ready workforce that will lead the charge in technological advancement and innovation. Once again, I welcome you all to this exciting program, and I wish you all the productive and enriching learning experience. Thank you very much.
Thank you, sir,
Thank
for
you.
your insight and valuable speech towards this topic. Next, on this momentous occasion, I would like to invite our today's chief guest, Dr. N.M. Sivaram, Assistant Professor, Department of Mechanical Engineering, National Institute of Technology, Pondicherry. Despite being busy schedule, he has given considered for our FDP. Once again, I welcome you, sir. I will hand over this session to our resource person. Sir, voice is not audible, sir.
Yeah, is it now audible now?
Yes, sir. Yes, sir. Audible.
Thank you, Professor Prabhu, for this opportunity. A warm good evening to one and all present here for this FDP. And so basically, FDP, as Principal Sir said, is one of the most professional tool or professional networking we can develop using this FDP and get to know about each other's specialization, their expertise, and collaborating with one another, because it's not very easy for us to learn and to practice not many skills by on our own. So basically we need to collaborate. That is very important, and collaborative success is always very high when you compare with an individual success. So that is one of the major idea behind conducting such as FDPs. And moreover, nowadays we have this virtual conferences. Virtual modes are there. It is a very good opportunity to learn from, to connect to everyone from across the world, across our country. It's a very good opportunity. So in that regard, I congratulate the entire team of JCT College of Engineering and Technology for organizing such an FDP, which is holding the theme of Industry 4.0, which is actually one of the theme that is actually being into a sort of a maturity phase now. If you see the start of Industry 4.0, it roughly started in 2015. And it is expected to last till 2040, 35, 40, somewhere around 2040, in another 20 years, 15 years. Now it is sort of in a maturity, it's entering into a growth stage, and so it is the right time to have an FDP on this context. So once again, I congratulate the organizing institute for providing this FDP on this topic, which will be helping all the people who are involving in this particular FDP. That's all from my side. Once again I thank the organizers, JCT College of Engineering and Technology, for providing this opportunity to present or to share whatever I have or I know about this particular topic, Industry 4.0. Thank you. Professor Prabhu?
Sir, tell me, sir.
So when should I start the session?
So now you can start, sir.
I can start now because still another 12 to 13 minutes are there. Is it fine if I start now?
Sir, I already posted, sir.
Okay.
The information to the group, sir. So you can join. You can start here. Sir.
Okay. Just a minute. I'll share my slide screen. Professor Prabhu, is my screen visible?
Yes, sir. It's visible, sir.
My voice is audible, right?
Yes, sir. Voice is audible, sir.
Yeah. So let me start from here. So good evening, one and all, once again. So the topic which I am going to present today in this particular FDP is Industry 4.0 technologies for manufacturing sustainability. So as you all know, Industry 4.0 is a manufacturing paradigm, first of all, and So it also focus on the sustainability. So what is sustainability that we will see, of course, when we enter into the third or fourth slide. So I am Dr. Sivaram, working as assistant professor in the Department of Mechanical Engineering, National Institute of Technology, Pondicherry. So I have been working there for the past 6.5 years. I have been there since June 2018. So before that, I had my PhD studies in PhD College of Technology, MTech in NIT Tiruchirappalli, and BTech from again PhD College of Technology. So this is about me. So moving on to the presentation. So coming to the introduction. So so as this entire FDP is focused on hello.
So your screen is not visible, sir.
Just a minute. How about now?
So now visible, sir.
Okay. So so as the FDP says that it's going to be deal about the Industry 4.0 techniques. So first we will have a brief understanding about what is Industry 4.0. The first couple of slides. So Industry 4.0 is basically integrating the digital technologies, the digital intelligent technologies into manufacturing and industrial processes. So this is one of the a very simple definition that you can put up for Industry 4.0. So already you have certain manufacturing and industrial processes, and you can and we sort of bringing the digital technologies or integrate the digital technologies into the existing manufacturing and industrial processes to enhance the productivity. So basically, in any industry, if you talk about the productivity is one of the key parameter or key indicator by which the success of the industry or the success of the manufacturing processes are decided. So putting into or integrating these two the manufacturing process and digital technologies, we call it as the Industry 4.0. Of course, we had Industry 1.0, 2.0 and 3.0, which are the three paradigms which we have already come across in the last 200 years. And this Industry 4.0 has been in existence, say about from the year 2015. That's where people started to talk about it. And it is expected to go around, to be in practice, maybe around 2040. 2040. That is the estimated timeline. People are expecting this to be taken over by Industry 5.0. So coming to sustainability. So my topic today is on manufacturing sustainability. So to define sustainability is as simple as that. We can say that we have to use the existing resources not only for us, it has to be retained for the future generations also. So that's what United Nations has defined. It's way back in 1987 itself. That sustainability is the meeting the needs of the present without compromising the ability of future generation to meet their own needs. Which means that we have to think about utilizing the resources in a proper manner, and we have to think about more on the circular economy, which of course we'll be touching on what is a circular economy, because circular economy is the key word, or people are working a lot on circular economy. So which has direct correlation or influence on the sustainability. And coming to the importance of sustainability in manufacturing, as I told you, any manufacturing process will depend on or will always focus on increasing productivity. So enhancing resource efficiency is a way of sustainability in manufacturing. Similarly, minimizing the environmental impact, impact in the sense reducing the footprint on the environment. It can be a carbon footprint. It can be any sort of negative footprint which you do, which you make it on the environment, is not a sustainable way. So we have, we are focusing. It has to be the waste has to be reduced. Energy has to be optimized. Energy consumption has to be optimized, and all sorts of carbon emissions has to be replaced or with other sources of fuels, not fuels, with other sources of energy to promote long-term ecological balance. So that is the importance of sustainability in manufacturing, because if you look at Industry 1.0, 2.0 and 3.0, this focus on sustainability was missing in the earlier three paradigms, whereas Industry 4.0 is more focused on the sustainability aspect. Because in olden days, if you see, if you talk about Industry 1.0, Industry 1.0 started by developing the steam engine, and then you move on to your petroleum-based power resources, whereas all those power sources or energy sources are not sustainable in nature. Steam requires coal, which again it negatively impact on the environment. So importance of sustainability is the key feature, or it is the central point of the Industry 4.0 paradigm. And coming to, again, that's what I told you, how Industry 4.0 contributes to sustainability. It contributes by way of enhancing overall efficiency, minimizing resource usage, and minimizing energy usage, and optimizing production. So this is how Industry 4.0 contributes to sustainability, which is a key parameter in terms of the United Nations Sustainable Development Goals. Now, if you see if you just Google it, UN SDG, Sustainability Development Goals, the United Nations actually is giving its utmost importance for the Sustainability Development Goals. So moving on to the next one, next slide. So again, as I told, Industry 4.0, the other way is to, it's another definition, it's a rise of digital industrial technology, allows us to work alongside machines in new and highly productive ways. So our ultimate aim is to increase the productivity. At the same time, we have to ensure it is sustainable. So that is very simple definition for Industry 4.0. And if you see, all these aspects are integrated together. There is an industry in the middle, and if you see, it is encompassed, or it is circled by energy consumption, it is circled by the design and development or manufacturing processes, then use of digital technologies, use of smart technology, smart manufacturing aspects. So all these things put together, you call it as Industry 4.0 paradigm. And if you see the development, industrial revolutions, the timeline of industrial revolutions, you can get to see this image. So Industry 4.0, it actually initially this term was defined in Germany. You can see the source citation for this. So this is the National Academy of Science and Engineering. There's a paper which actually talked about this industrial 4.0. If you see from the late 18th century, so now we are in the 21st century. The late 18th century, it is close to 220 years or 250 years before. So first industrial revolution, it started with power generation or power loom. So the power loom was introduced in 1784. The mechanization of production facilities with water and steam power. So basically, steam engine is the beginning of industrial revolution, and this steam engine was used to power the power looms in 1784. And this is the start of first industrial revolution. Then, of course, the first industrial revolution was going for a bit longer time, maybe even up to the 19th century. There were not much developments in the industrial revolution. So when does the second industrial revolution started? It starts with the invention of electricity. So when electricity was introduced, then they had this mass drive for industry 2.0 paradigm. So also you can also see that there was an assembly line practiced in slaughterhouses in 1870. So these two are taken to be the starting point of industry 2.0. Then you had industry 3.0. We had industry 3.0 in 1970s, where primarily the computer controls. So initially the invention of power, steam power, then invention of electricity, then invention of computers. So invention of computers and controlling of certain processes by computers, it actually introduced us to industry 3.0. Of course, as computers, we also had the PLC circuits, programmable logic controllers, where most of the assembly automation is based on, and growing as application of electronics and IT also contributed to industry 3.0. And coming to industry 4, so if you see industry 4.0 was initiated as a future project by the German federal government. So they identified that this is going to be the future, and they identified that, and they started this by they started this by understanding that integrating both physical systems with computers is going to be the future. That's why they coined the term cyber physical system, that is CPS. So this is the basis for industry 4.0. Where you integrate your manufacturing process or any process with your cyber systems, the computer-based systems. And if you see, this is how the industry 4.0 has was started, and now if you see, it is expected to go around up to 2040. So that is the expectancy. And if you go until 2040, so if you see the general product life cycle curve, or how a product life cycle is managed, if you roughly see now, it is almost we are into 10 years of this industry 4.0. So that is almost we are entering into the growth stage. So initially we have been in the introductory stage where some basic research activities were happening. Now we are going to the growth stage. Then there will be obviously a maturity stage will be there, and then there will be a decline stage. So this is how it is expected to go, and we are pretty much in the starting of the growth phase. So you can also refer the product life cycle curve, how it works. You can Google it. You can see how the product life cycle curve looks. So this is the timeline of the 4 industrial revolutions we had so far. And of course, the last one, the industry 4.0, is we are still progressing into. So moving on to the next slide. So what are the key industry 4.0 technologies? So now if I would like to list out some of the key technologies. I think Professor already listed a few of those in the introductory speech. So if you see the technology 1, or the prime technology, is the Internet of Things, which is considered to be the base for industry 4.0. So if you talk about Internet of Things, it's a system of interconnected sensors. It is basically you connect your sensors, devices, machines. So these Internet of Things, or this Internet of Things, is basically a connection of all the digital devices and all the machines. So the machines speak to each other by means of Internet of Things. So it is like we have 3 or 4 machines, and all these 3 or 4 all these machines are controlled by some digital devices, and the digital devices control them or give command to the machines based on certain inputs which are received from the sensors. So that's how this works. So it is Internet of Things is a system of interconnected sensors, devices, machines that collect, exchange, analyze data in real time, so that this process can be improvised or efficiency can be improved. And for example, certain things or certain applications are
predicted. Excuse me, sir. Sorry.
Yes.
Sorry to interrupt. Your screen is not available, visible.
Just a minute.
Sir, it's stuck, sir.
Now is it visible?
Yeah, sir, visible.
I think there is a problem with my browser. I will just go to Google Chrome. Just a minute. Spare me a few minutes.
Professor Prabhu, can you see the PPT now?
Yes, sir.
Is it moving? I think
Yes, sir, everything is moving, sir.
okay. So let me continue. Sorry for the disturbance. I think there was a problem with the browser. So technology number one, the basic technology for Industry 4.0 is Internet of Things. And if we talk about Internet of Things, it is basically an interconnection between sensors, devices, and machines. So data from the sensors will go into the machines, and the machines are basically controlled by certain devices. And these devices are interconnected on the internet. So you can find a number of examples about Internet of Things, the web sources. So basically, this Internet of Things can be used to predict the failure or predict the breakdown, expected breakdown in the machine. It can by predicting the breakdown, we can be prepared for the equipment maintenance. So we can reduce the downtime, and it's also this data whatever we are receiving about the machines will also be on the energy usage. So which will be used, or the data will be analyzed and used for energy optimization. So this is one of the basic technology or the foundation for Industry 4.0 technologies. So for example, an example is Siemens smart factories, which uses IoT devices to monitor energy consumption, optimize equipment performance, and reduce material wastage. So these are some of the examples of Internet of Things, which is one of the pillar. If I say that we will be going through some technologies. So there are 10 pillars. We assume those to be the 10 pillars. This is one of the foundation pillars for Industry 4.0. Moving on to the next technology, that is technology number 2, that is artificial intelligence and machine learning. This is, of course, there is no need of introduction about this, because this is very much known to us, or known to everybody in the present scenario. So artificial intelligence, the use of AI and machine learning to process large data sets. So that is the major application of AI and ML. So you will have a large amount of data for the machines which are operated in the industries. So these large data sets are used to process, are used to identify, or used to predict the pattern of certain variables in the Industry 4.0 setup. Say, for example, in the previous slide, I told you about the maintenance. So we can predict based on the usage, based on the process parameters or the output responses, you can call it another way, for certain processes. We can predict when this process is going to change its direction, or when the process is going to there is a need for a change in the pattern or change in the behavior. All these things can be understood from the AI/ML techniques, which primarily focuses on the processing data sets to identify the patterns and to decide or to make certain decisions. And this AI and ML will have more algorithms, because it is an extension of optimization. So this AI and ML is not new to us. We have learned about optimization. So we are going to optimize this AI and ML with a bigger data sets. So that's what we have been so far optimizing process parameters. Maybe it may be a single objective optimization or multi-objective optimization with lesser number of data sets. But nowadays, when you have more number of data sets, you need more computation, you need more different algorithms to process these data sets. So each and every algorithm will have their own advantages and disadvantages. Some algorithms are more accurate in predicting, but they may not handle more data sets. Some algorithms will handle more data sets, but the accuracy of the algorithms will be less. So nowadays, every day you have many algorithms being developed. Even one of my colleagues is doing a project where he's trying to identify the health level of various plants by using the thermal imaging camera. So by thermal imaging camera, he takes the photograph of those certain plants every day, and he tries to connect the thermal imaging data with the health of the plant. So when the plant is expected to get some infections, or when the plant is expected to not to be edible, or so some sort of correlations he is trying to develop. So for this, we need to have more algorithms. So whatever optimization techniques we have been using is not sufficient. So that is one of the reasons why this AI and ML is very helpful in processing large data sets. This AI and ML will help in process optimization, quality control, and some of the best example is Tesla. So Tesla uses artificial intelligence-driven robotics and machine learning algorithms to enhance precision in manufacturing. So that is very important. You need to be accurate. You need to identify the best optimum process parameters, so that you produce the same component, or you produce the end product is very much similar, and that's what you call as precision. Precision is nothing but repeatability. You want to repeat your process, you want to repeat your results as maximum as possible. So we call it as a precision. So this is very much important in the industrial setting. So this initially I'll just go a little bit faster, so that when we go after say about some slide 12 or 13, we'll be more focused on the sustainability aspects. So the technology 3 is big data and analytics. Again, as I told you, AI and ML is used for large data set processing. Again, big data and analytics is also a similar process where you collect large scale data from industries, from machines. Say even for you take a small sensor, you are wearing a smartwatches nowadays. We have the habit of wearing smartwatches, so our data are recorded. So similarly, many people are having their own personal data, and all these data are recorded. So when all these data are clubbed together, it becomes a big data. So big data is nothing but the volume of the data. So big data and analytics, large scale data collection and processing for decision making. So this is the prime role of big data and analytics. So it is used for predictive analysis. So again, most of these industry 4.0 technologies is used for prediction. So when the machine is going to fail, when the machine is going to behave in a different manner, when there's going to be a need of when the temperature is going to rise in the process, when there is a need to increase the humidity in the process. So all these settings can be predicted. So that is the biggest advantage of Industry 4.0 and real-time monitoring. We are nowadays, if you see all the data you get in your the engineers in the industry, they are getting in their own computers. You just go to any chemical plant, a big computer screen will be there, and with the computer screen, they will be having all the data, the pressure levels of all the tanks, storage tanks, what is the pressure of the valves that are operating, particularly when they're using the cryogenic liquids or cryogenic fuels. It's a two-phase flow, and what is the pressure of the cryogenic liquid in a liquid state, what is the pressure in the gas state, and how they are controlled. All these things they have on a big screen. So that is possible by big data analytics. And you can see GE uses big data analytics to continuously track turbine performance. You know, GE is one of the major equipment supplier for both. Is the jet engine supplier for any aircraft manufacturer. The jet engines are manufactured by General Electric. So they want to track the turbine performance, and turbine performance is very crucial because it is the critical part of the aircraft. When the performance is lost, even there may be high chances that the aircraft may lose its thrust. So because of that, they want to monitor and they want to get the data into the computers, and they want to analyze the potential failures. So even some 4 to 5 weeks back, there was a news that there is a small damage that was identified in the jet engine. A small, not even a small crack. It is very minor change in the topography of the surface. There was a small change in the topography. Surface topography is the profile, you can say. A small profile change, and that was identified by these sensors, and that jet engine was not used for that reason. They are just going to modify that. Whatever the problem has occurred, they want to rectify it. So that is the level of importance of the jet engines. And in order to ensure a safe flight or to have the best performance of the turbines, big data analytics help. So that is the technology 3, which is used in the industry 4.0. About industry technology 4, then of course the very known to us as a mechanical engineers. We are every day we hear about this term 3D printing. So it is additive manufacturing. So conventionally we had subtractive manufacturing practices where you try to remove the material, particularly in the machining operation. We remove the material, but this one additive manufacturing, we add layers of material so that we develop the product. One of the major advantages this layer by layer production of components is will reduce the material. So that is the major advantage, as we all know. Lightweight components and energy efficiency, all these are put together. And nowadays, if you see even some of the space components which are used in spacecrafts, satellites, all these things are manufactured by additive manufacturing because they offer you lightweight components. So when you go for a conventional subtractive manufacturing, the weight of the components are increased because certain intricate shapes cannot be produced by subtractive manufacturing. So for that, we compromise with the overall shape and size of the product. Whereas by means of additive manufacturing, we can optimize the material wastage, we can optimize the shape of the product. With that advantage, we can even produce very small micro and nano sized components. Nano in the sense in the range of 1 to 100 nanometers, that is the range. So even nano sized components can be produced by additive manufacturing, which are nowadays being used in space technologies. And of course, Airbus also uses. So when you talk about lightweight components, obviously it will be used in space systems, not in ground systems. So yeah, the very much essential requirement for any space system is going to be lightweight products. So 3D printing is used by Airbus, which produces lightweight aircraft components, which reduces material usage, improves fuel efficiency, and minimizing production use. Going on to the next technology, cyber physical systems, that is CPS in short form. So cyber in the sense you call it the computers, and physical systems, your physical manufacturing and industrial systems. So when you integrate these two things, then you call it a cyber physical systems, and all the cyber physical systems are controlled by means of digital infrastructure. So once you do this, you call it as a smart manufacturing or smart automation, which gives you better monitoring and control over the process. So instead of me physically going and verifying certain process parameters, the sensors will give the data back to the controlling stations. So this cyber physical system is already being in practice. Most of the, say the case of a nuclear reactor, they use cyber physical systems. You take the case of satellite components, satellite communication, they use some cyber physical systems. So basically it's an integration of physical systems and the computers. So this is also one of the key technology which is required for Industry 4.0. About cloud computing, so this is another technology which is very much necessary, because cloud computing is necessary because nowadays you have all these data, all these data sets are connected in and stored in cloud. You don't have any physical storage devices, because if you have any physical storage devices, it is impossible to store these many data. And so we have remote storage, and that is very much essential, because even if you take the case of a smart home automation, there should be a storage space to connect, to get all this data, and this data has to be given to the appropriate devices. So this is done only by means of cloud computing, because nowadays we are connected through the internet. So this internet requires some storage space, and this is nothing but cloud computing. I'm not much well versed with cloud computing. So, but as a Industry 4.0 technology, this is also another base infrastructure that is required. So that is nothing but the IT infrastructure. So IT infrastructure is very much essential in Industry 4.0. Without IT infrastructure, without a good sound IT infrastructure, it is impossible to realize the Industry 4.0 paradigm in any industry. You can see Unilever uses cloud computing for supply chain optimization. So Unilever is basically a company which supplies most of the domestic products, household products. So they want to optimize the supply chain, and that has been done by reducing excess inventory and waste. And how these data are gathered and they are distributed, it is distributed by the cloud computing. Coming to this technology 7, and this is a very fascinating one. It's very one of the best technology, which I would say for the mechanical engineers to work on. So DT is a chart format. So this DT is basically a virtual replica of the physical assets for simulation and optimization. You have a physical asset, say for example, I have a battery. I have an electric vehicle battery, and the same electric vehicle battery can be simulated as can be generated in a digital form. So whatever the battery, whatever the condition undergoes, the physical battery undergoes, the same conditions are simulated for the virtual battery also. So by simulating these two, you will have whatever the conditions or whatever the responses that is experienced in the virtual battery, you can expect the same to be occur in the physical battery also. So it is again more like a predictive maintenance. So you are predicting the failure, you are predicting the behavior of your physical product by creating a virtual product with the same physical or same environment or same parameters in which the physical product is working. Another good example is your engines. Nowadays, all these engines, the power plant engines, are having digital threads. So whatever happening on for the virtual product, the same is expected to happen for the physical product also. But this again requires a lot of computational facility, because you want to create a digital model, you want to integrate, you want to create that working environment. So I think ANSYS has come up with one of the software for this digital twin. It's a very new. It's a very new to Industry 4.0, this digital twin. But of course, in another 2 to 3 years, this is going to be one of the very much key element of Industry 4.0. And the next one is robotics and automation. As I told you, as we all know, Industry 4.0 means it's increasing productivity, and increasing productivity can be achieved by employing robotics and automating the manufacturing lines. So robots are used. Robots can be a normal robot, or it can be collaborative robot where the humans and the robot work together. We call it as cobot, C-O-B-O-T. So this robotics and automation is also a very key element of Industry 4.0. This, of course, again, this has been in practice for a very long time. If you take Japan, they have been using robots from 1970s onwards. Even in India, we have been using robots for assembly line, for manufacturing, particularly vehicles, automobiles. Automobile assembly line, we have been using robots. So there is nothing new in Industry 4.0, but there are certain things which are collaborated together, and so that the net efficiency of the entire collaboration is much higher than what we have been seeing so far. And digital twin is a very new technology. There's no doubt about that. But certain other components, certain other technologies, we have been using that, but those have been used in a standalone condition. They have not collaborated. So that is the basic understanding we should have about Industry 4.0. And technology, next technology is blockchain. Again, this is another new, it's very much essential, the blockchain technology. Again, it's more towards your computers, your programming architecture comes into picture here. So it is like a digital ledger. So blockchain is nothing but you need to secure, have secure transaction channels, just like what you are doing for your payments, your online payments. You have secure transaction modules for that. Blockchain is also a secure transaction module. It's a decentralized digital ledger. So which ensures that whatever data comes in and goes out are all having proper records, are all recorded properly, are all happen. They have authentication, that the user should validate that this is the data supplied by them, this is the data they are, that is retrieved by them. All these authentications are present in blockchain technology. Because one simple example is take the case of a supply chain. in a supply chain, I should know that there is a particular demand for this particular product in this area. But there can be some false data where stating that there is a requirement for a particular product in a particular area. So to understand, to differentiate between the false data and the proper data, we need to have an authentication. So this authentication is provided by blockchain technology. For example, even in internet, when we browse, sometimes there may be a confirmation asked to us whether we are a robot or with some it will ask us to click some images. It will ask us to click some captcha code. So all these are a form of blockchain technology, which tries to block the bots, which the bots are generally developed by certain group of people to manipulate certain things. So to understand, to authenticate the data, blockchain technology is very much necessary in Industry 4.0, because if you see the basic operation of Industry 4.0, they are more focused on IT infrastructure. IT is one of the major support systems for the Industry 4.0. So whatever the data you are getting in, whatever the data you are getting, it's getting out. All data has to be authenticated properly, and this is done by blockchain technology. Coming to the last technology, the AR and VR, the augmented reality and virtual reality. So it is nothing but, so there is not much difference AR and VR. Augmented reality is nothing but it is an integration of your normal digital softwares where you develop a product, you try to create an animation about a process in the digital platform. So that is nothing but augmented reality. Whereas virtual reality is nothing but you can fix a headgear or you can fix an eye gear, and you can visualize that, and by doing certain actions by your hand. So you can visualize the action, and the same you'll be able to experience by your hand. It is nothing but the virtual reality. So this AR and VR are very much used in Industry 4.0 for data visualization and training purpose, immersive training purpose. So if you see some technologies where the trainers, the operators, they are given this VR technology, they are trained of how to operate in a machine. It's like a simulation. You can operate those machines by using this AR VR virtual platform, so that when you go to the actual machine, the real-time machine, the operators will be much familiar with the operations. It is very useful for particularly in servicing of machines. So if you see the Boeing aircraft manufacturer, they use their technology for virtual assembly guidance. So that is one of the things that the product manufacturer will have assembly, will have disassembly. So before going to the actual assembly part, VR helps to give a virtual assembly experience. So which will reduce the errors that is happening, and which will also reduce the time that is taking place for the actual assembly and disassembly operations. So these are the basic 10 technologies, the foundation for Industry 4.0. So first we saw about Internet of Things, IoT, artificial intelligence and machine learning, AI and ML, big data analytics, additive manufacturing, cyber physical systems, cloud computing, digital twin technology, robotics and automation, blockchain technology, and AR and VR technologies, augmented reality and virtual realities. So if you talk about their impact on sustainability, all these technologies are used in smart grids, especially for improving the energy efficiency. They are used in AI-driven optimized energy consumption. So they have more applications nowadays you will see on the energy reduction and energy efficiency. And also waste reduction, they are used where the predictive maintenance of the machines and precise automation controls are done by these technologies. Then eco-friendly materials, which again contributes to sustainability. So first one is energy efficiency, which when there is an energy efficiency, there is an increase in sustainability. When there is a waste reduction, by predicting the maintenance and precisely controlling the automation, there is a waste reduction in the entire process, which again increases the sustainability. Then eco-friendly materials. Additive manufacturing can use any type of material, and more eco-friendly materials are being put into use. So when you are using eco-friendly materials which are friendly for recycling, then again you are increasing the sustainability indicators or sustainability index of your process. Then finally, supply chain optimization. This Internet of Things and big data analytics, they combine huge data from various supply chain nodes. The supply chain system, if you call it, there will be different. Say, one product will originate from the manufacturer, then it goes to the warehouses, it goes to the dealers, finally it goes to the consumers. All these things has to be monitored properly, and this is done by IoT. And this also increases sustainability index of a process. So these are the major 10 technologies that are available for your industry 4.0. So moving on to the next one. So now I will the next part. So this is the first part. We have seen what are the technologies available. The second part is we will see the applications of these technologies. Some of the things I have already told you, but some more specific applications we will see in terms of sustainability. So my talk is focused on Industry 4.0 technologies for manufacturing sustainability. So how sustainability is increased by means of these technologies will be seen in this. So Internet of Things and AI for sustainability. So we have already seen brief overview of Internet of Things and artificial intelligence. IoT refers to the network of physical devices, as I already told you, and AI is the simulation of human intelligence in machines. So the machines are actually given a big data, a huge amount of data set, and by means of these data sets, the machines they themselves tries to think and solve the problems autonomously. So that is nothing but AI use of artificial intelligence. So how this is applied in the real time. So if you see the how IoT devices collect real-time data and how AI processes that data to optimize operations for sustainability. IoT device data collection. Basically, IoT devices continuously monitor and gather real-time data from their environment, like smart thermostats. You can see some thermostats will be there to monitor temperature and adjusting to heating and cooling to save energy. So that is one of the example. Smart meters, smart energy meters that is used to track energy usage in buildings and homes. Environmental sensors which can be used to detect pollution levels, air quality index and water usage. Manufacturing sensors which is used to track machine performance. All these are an example of IoT device data collection. So these devices are used to collect the data, collect the corresponding data. Then after that, how does AI process these data for sustainability? So AI analyze these data and try to identify a pattern. So AI process the real-time data from the IoT devices. Some of the few examples, whatever I mentioned was a few examples. You can have n number of examples for IoT devices. And data analysis and pattern recognition, the AI tries to identify some pattern. So it understands the process. It tries to identify a pattern. So by identifying a pattern, it tries to reduce the inefficiencies or to recognize the inefficiencies and also to predict the future trends. How does the trend goes? For example, by having some data on the acoustical sound, say if there are some sound which is coming from the machines, even by recording such the sound and by analyzing the sound, you can predict when the machine is going to failure or when there is going to be a problem in the machine. So that is an example. By tracking the historical data, by analyzing the data, and by identifying a pattern, the AI is actually helping the sustainability part. Then second one is optimization. AI helps to optimize energy usage by adjusting systems in real time. For example, AI will analyze the energy consumption data, and based on the ambient temperature, if it has to operate, if it has to increase the temperature or decrease the temperature, it can be done through optimizing the AI data. Similarly, in agriculture, IoT sensors, they actually monitor the soil moisture, and by measuring the soil moisture at different places, it gives an understanding where and when the irrigation should be done. So, which actually helpful in reducing the water consumption and also power consumption, which will indirectly help the sustainability part. So this is how the AI, the data processing by AI is connected to the sustainability. Then, of course, another example is the predictive maintenance. AI processes data from various IoT sensors in manufacturing or transportation system. It's like the data of any machine in any form, like it can be sound, as I told you earlier, it can be the number of products produced, it can be the tool changes, what is the time period between tool change, or what is the machine, what is the combination of the tool and the work, what is the combination of the materials that are used in the tool and the work. By analyzing all these combinations, it can predict some period where the maintenance of the machine is when the maintenance of the machine is required. And smart decision making, as I told you, AI uses real-time data which can adjust the operation of wind. For example, there is a wind farm is there, and the wind farm is producing power by means of windmills, and by collecting weather data, by collecting the meteorological data, we can analyze the wind direction over a period of a year. So in certain periods, the wind direction is going to be in one direction. In another, for 3 or 4 months, the wind is going to be in another direction. So based on this, the direction of the windmill also can be modified or it can be altered, so that this will help in improving the sustainability. So these are some of the examples. These are all not whatever I'm showing you, it is not anything that is limited. These are some of the examples. And what AI helps in other thing is, as I told you, is energy consumption with IoT and AI. It primarily focuses on sensors, IoT sensors, real-time monitoring and data collection. So this is the major inputs that are given by IoT and AI. And artificial intelligence, in addition, it uses various algorithms to predict and optimize the process parameter or the process responses. In our case, I am talking about energy demand, because energy demand is an indicator of sustainability. So when you can reduce the energy consumption, you are increasing the sustainability aspects. So AI algorithms increase the energy management, demand prediction. For example, this very classic example nowadays we have all the power is connected to the grid. So that if you get the data from the grid, you will know in which location power is being utilized more, or which location power consumption is higher in a particular field. So these predictions are like this. AI is a much needed tool for optimization purpose. It's an extent of your optimization techniques what we have been using so far. So that is one of the major applications of IoT and AI for sustainability. This is one of the examples, this energy demand. And real world application, as I told you, the smart thermostats, devices like Nest or Ecobee, they learn the user preferences and adjust temperatures for optimal energy usage. Because even if you don't turn out or switch off your air conditioner or don't control the temperature, the thermostats will automatically bring you back to the optimum temperature. So it is used for energy conservation and sustainability. And intelligent lighting systems. So smart lighting systems adjust brightness based on natural light level. So you will come across the Philips Hue lights, which you can adjust the brightness, and also you can depending on the environment you want. If it is a learning environment, you need the lighting. The temperature of the lighting will be 6000 K, whereas if you want to have a very soft environment, then you want to go for your temperature around 3000 K to 4000 K. When you go around 7000 K temperature levels, it goes to a very bright environment, which are used for very sensitive operations. Like you take the case of medical operation theaters. You take the case of a person who is repairing the watches. If you go to a watch shop, you will see that person is working in a very high illuminated environment. So that is depending on the temperature, depending on the light intensity, certain works will be carried out. So for optimizing that, people use the Philips Hue as an example. It can adjust the brightness on occupancy and also based on the natural light which is available in the open environment. And energy efficient smart buildings. Nowadays you have such type of smart buildings, and in India we have the green building initiatives. The Griha Council is there, which the expansion is Griha is green rating for integrated habitat assessment in India, which gives ratings for each and every building, which uses the energy conservation concepts, which tries to utilize, reduce the energy consumption by adopting or by including the utilization of natural lighting, natural ventilation, and using some materials like which are giving a cool environment inside the building. Like it can be a phase change material, it can be brick. Nowadays you have this porotherm bricks. Porotherm bricks are very common nowadays, which gives you a very cool environment inside the building. So Griha Council is nowadays many it's very mandatory to build green buildings, and for building these green buildings to have such type of IoT and AI will be helpful in developing smart cities and buildings. So of course we have similar initiatives in Singapore, in Master City in Abu Dhabi. All the cities nowadays, all across the world, they want to develop green buildings. And to develop green buildings, you need to have a large amount of data. You need to have the data processing by means of artificial intelligence. So this is one of the examples where IoT and AI is used for sustainability purpose. Then, of course, another example is IoT in waste reduction. IoT is used for monitoring material flow. IoT sensor for material tracking, manufacturing industries, agricultural industries, supply chain visibility. The supply chain network is a very critical network. If I want to take a material from point A to point B, and if I by mistake, if I take the material from point A to point C, then whatever the energy I have used for transporting the material from point A to C is a waste, and it's against the sustainability limits. So we want to ensure the entire supply chain is operated in an optimum manner. So for this, IoT and AI helps. And AI for waste optimization, recycling. AI is used for sorting materials also nowadays. Say for example, as I told you one example, one of my colleague is working on processing the images from a plant by means of in terms of thermal imaging camera. So similarly, we can use images of different materials. We can use the images to sort. Say for example, aluminum is there, if there is a brass, if there is a copper. By just capturing the images of aluminum and training your AI model, your AI algorithm, many times, we can sort the materials just by capturing the image and feeding into the AI model. You can say that this material is aluminum, this material is brass, or this material is copper, and so on. So it also so this is how AI sorting helps. So this can be this model can be used in solid waste management, because nowadays we have huge number of solid waste piled up in if you go to any municipality, if you go to any city or town, solid waste is a huge problem, and many useful materials are present in the waste piles. So this can so such type of AI models can be used to analyze the image of any waste pile, and we can try to identify if there is any useful material present there or not. And AI to predict waste trends, again, waste forecast, like just the case of how you predict the failures. It is also used to predict the waste. Waste in the sense, say for example, if a material is not, if the energy is not consumed in an effective manner, so what is the approximate amount of waste it is going to produce? What is the end effect? There is so many number of people are not using the energy in a proper. So such type of ends also can be predicted by AI models. And the best, so these are the best some of the examples. So one is optimizing waste collection routes. You can have smart sensors on bins, dynamic collection scheduling. So say for example, this dynamic collection scheduling, the example is in some cities there may be waste collection procedures. So in a street there may be a person who is coming at 7 a.m. or 8 a.m. in the morning, they will be collecting the waste. But during that time there may not be waste generated in the households. Whereas if you alter the schedule to 9 a.m. or 10 a.m., there may be a significant amount of waste produced. So this is one of the examples. So there should be, the collection schedule should be dynamic based on the data what we are getting from the actual operations, that is the manufacturing industries and the manufacturing processes. And AI enhanced recycling practice, smart waste sourcing. So again, this data will have, so what type of waste materials are present in which part of your the world, and accordingly, Big Belly is actually a company which uses this AI practices to sort the waste, or to sort the waste which they require in an effective manner. And again, smart cities waste solutions. Songdo, South Korea, they use advanced waste management systems, like IoT and AI, to track waste generation, optimize pickup schedules, and ensure high rates of material recycling. Another important applications of IoT and AI is your predictive maintenance. They try to track equipment health, early warning signs, give early warning signs. They analyze IoT data like unusual vibrations in motors or temperature spikes in engines. All these unusual data, not unusual data, all data will be recorded and it can be used to analyze. And one example is GE, which they use the Predix platform, uses IoT sensors and AI to monitor turbines. As I told you this turbine example earlier. So GE General Electric uses their own Predix platform to analyze the turbine performance, predicting failure and scheduling repairs before the breakdown occurs. And when you use this AI and IoT, we will have data-driven decision making for sustainability and efficiency, because any decision making has to have some base data, and this can be provided by monitoring them or tracking them by the IoT sensors and feeding them in the artificial intelligence algorithms to optimize them, to optimize the input parameters, to optimize the output responses, and to map them so that we can get faster and we can make faster and smart decisions with the base in the real-time data. So this is one of the major pillars of this IoT and AI is one of the major pillars of Industry 4.0 technology. Then coming to the next two, there is the big data and digitalization, how these two things are combined together. So as I told you, big data is nothing but extremely large data sets that are very complex in nature, and it is difficult to process with traditional data processing tools. So the main challenge in big data is the 3 V's. One is the volume. The amount of data are very high, or it is massive amounts of data are generated daily. The speed at which the data are generated is also very high. The velocity of the data and variety, the diverse types of data from structure and unstructured, such as images, text, and sensor data. Any sensor you have, all these data are produced. And all these data are high in volume. They are high in velocity. That is the speed at which the data are created. And it is high in variety also. Various types of data are produced. So to monitor or to understand this data, you need big data analytics. And coming to digitalization, what is digitalization? Digitalization is nothing but you try to convert the information into a digital format by any digital tools. So this will help towards sustainability. Digitalization gives you better view of the entire process. You can visualize the process on your dashboard when you have digital data, and this can make you this can ensure you to make real-time decisions based on the real-time data what you have from your sensors, AI-driven algorithms. So how to leverage this big data for sustainable sustainable decision making? If you come to data-driven insights, what you call data-driven insights, because this data-driven insight is nothing but a detailed insight of the resources. Like it can be energy, it can be water, it can be materials. These insights will help to identify the inefficiencies in the process. So, for example, companies having when they want to use and they want to optimize the supply chain, they need to know where they're lacking, where the waste is happening, where the energy is spent unnecessarily. So this is, say for example, just by fixing a small GPS sensor, your geographical positioning system sensors, you'll be able to understand the movement of the vehicle. This is an example. And predictive analytics, big data, when you combine with AI, can predict trends in resource usage. So the best example is, say for example, as a retailer, I should know about the customer purchasing behavior. So only then I'll be able to handle or have stock of materials which customer wants and which customer does not want. So I should know the data. But this data is can be provided by the big data analytics by taking into account of the by measuring the customer purchasing behavior. So this is another example for big data analytics, because I have to store only the material which customer buys. Otherwise, it is an inefficiency of the entire supply chain. And supporting decisions, this is done by real-time data access, or optimizing and real-time data access. Real-time data access in the sense, only when you digitalize data, it can be available. It can be available in any instant. Say, for example, I open up my computer. I should have the dashboard to have all the data. So one of the very common examples is nowadays you have your smart vehicles, your automobiles, your cars, where the entire data is coming up onto the dashboard. Say, for example, just I switch on the car, I'll be able to know the data of the tire pressure. What is the tire pressure on the 4 wheels? That is an example for leveraging big data. So it measures the tire pressure at regular intervals and it gives the data. Similarly, the data on the fuel usage, the data on the driving behavior of a person, how the system actually correlates the driving behavior and the fuel usage also. So by it controls or it gives suggestion, so that stating that such type of driving behavior will increase the fuel efficiency. So these are all some of the examples of the big data analytics that will be helping the sustainable decision making, which again in turn will help the sustainability part. Coming to the circular economy, because this big data is very much useful circular economy, because circular economy is very much a part of sustainability. So what is circular economy? Circular economy is like, it is a recycling practice. So as a manufacturer, I will be selling the product, and once I sell the product, I should be able to have a methodology. I should be able to have a technique to collect the end-of-life products. They call the EOL products. And once the EOL products are collected back to the manufacturing plant, the same has to be recycled and it has to be used once again and again. So this is nothing but the circular economy. And this circular economy requires big data, because only big data will be able to track the product life cycle. Say, for example, there is a product, there should be a sensor fixed to the product, so that the product useful life is tracked by the sensor, and when the product is not used by the consumer, when the consumer discards it, the manufacturer should be able to identify the unused product and the faulty product, and he has to take it back, the manufacturer. This is known as the end user responsibility, the corporate responsibility for any manufacturers. It's very much practiced in countries like Germany in particular. Any faulty product should not be left out in the environment. If something happens like that, the manufacturer will be penalized for it. The manufacturer will be given the appropriate punishment for not ensuring the circular economy happening. So basically, you want to take back the unused product. That is a prime responsibility of the manufacturer. For that, big data is very much needed, and big data also helps in remanufacturing opportunities, because nowadays you will have some products are in refurbished conditions. So you should be able to know which part of the product has failed and you should be replacing that. It should be serviced. So, like Caterpillar uses such type of technologies. Caterpillar, Caterpillar is a very big company, mechanical engineering based company, which uses this technology and how to track returns and product lifespan. HP uses this to recycle the ink cartridges, what they were being manufactured and what they have delivered. They use the same principle. They use the sensors to identify where these cartridges are remaining, and they will be taking it back for recycling. So this should be a part of the manufacturer's commitment to ensure the process is sustainable. And digital twin, as I told you, digital twin is a very new nowadays. This digital twin is used to represent any physical product in virtual means, and whatever the data you are generating from the virtual representation, it is applicable to the physical product. The virtual product's data you can apply to the physical product. So whatever the problems the physical virtual product is undergoing, the same you can expect in the physical product. One example is the EV battery. So the life cycle, the life of the EV battery, you can simulate in the virtual environment. The same thing is applicable in your physical environment. This is one of the key examples of digital twin. So digital twins are simply they are the virtual representation of physical objects, and these digital twins are available in energy grids, factories for reducing waste, improving efficiency. Digital twins are used in smart cities. So these are some of the examples of digital twins. So how these digital twins relate to sustainability? So basically they are used to simulate the processes in a virtual environment, because as I told you, whatever process parameters, whatever the change in the process parameters and the responses are taking place in the virtual environment, the same is applicable to the physical environment. So it tries to simulate the processes, it tries to predict the future resources, and thereby it increases the energy and resource efficiency. So that's how digital twin works. So now you have a separate package given by ANSYS for the digital twin technology. I think one user itself is cost around some 6 to 7 lakhs. What I heard about that. So digital twin package is also developed by some of the computational tools. So this is what I meant with digital twin, where they are used in urban planning and resource management. One simple example is how to simulate the traffic flow so that energy distribution or energy efficiency can be improved, because each and every minute when a vehicle is standby in the traffic, you are losing energy. So digital twins helps to simulate the traffic flow so that the traffic systems can be improvised. Then one example is Singapore's Smart Nation initiative, where they use this digital twin technology particularly for urban planning and development. Then energy grids. So grid optimization, energy grids use digital twins to simulate electricity distribution in real time. Example, a company known as Enel, they use digital twins to optimize energy grid operations, because all power will be directed towards and out from the energy grid. So by creating a digital twin for that, they have predicted that when power outages may happen, when power reliability problems will occur based on the usage, based on the end user, and also based on the climatic conditions also. In summer you have high power usage. So all these things they can simulate using the digital twin, and thereby they can increase the energy efficiency and sustainability. and factories. Manufacturing efficiency also can be predicted by digital twins. And particularly Siemens, they use digital twins in its manufacturing facility to simulate production process and improve efficiency. So these are some of the examples of how digital twins are being put up in Industry 4.0 scenario. So, and coming to the next two major pillars of Industry 4.0 is additive manufacturing and automation. So, how additive manufacturing and automation improvises the sustainability. So 3D printing is what additive manufacturing is. Robotics. Robotics also help in sustainability. Artificial intelligence in manufacturing. It again, artificial intelligence as a standalone pillar, it contributes for some optimized conditions. The same is applied in manufacturing scenario. Some manufacturing systems are subjected to artificial algorithms, AI algorithms, so that you are optimizing the production process. So what you call it as smart manufacturing is the integration of artificial intelligence, robotics, and 3D printing. We call it as smart manufacturing. So there may be a 3D printing operation, and there may be operations which are controlled by robotics, and all these process parameters are driven by the AI optimized process parameters. So this is nothing but the smart manufacturing when you integrate AI, robotics, and 3D printing. So some of the real world examples are the General Electric uses 3D printing to produce complex engine parts. As I told you, this when you produce complex engine parts by traditional methods like subtractive manufacturing, material wastage will be on the higher side. Say for example, I'm using a machining operation. I want to remove the material. So whatever the material I have removed, again I have to recycle it and I have to reuse it. So the cost of recycling and reusing it, not only the cost, the use of resources for reusing, that can be minimized substantially by using 3D printing. So 3D printing can produce complex engine parts without material wastage or very minimal material wastage compared to traditional methods, which will reduce the overall production cost. Not only overall production cost, it increases the sustainability. BMW uses robotic automation in its production line to improve the assembly speed and accuracy. And not only BMW, even in our country we have been using these robots in assembly lines. But what differs from our traditional usage and the Industry 4.0 usage is the support of AI. So we can see the Siemens integrates AI in its manufacturing process so that the a large data set of the process parameters can be optimized. So that is the significance here. So it does not mean that we have not been using production line, automated production lines earlier. We have been using, but what the difference is the amount of data we have generated, the amount of data that is generated by means of IoT, and how AI is used to analyze that, and how you optimize the process parameters to increase the usage and or to optimize the energy usage, so that every step, whatever we are contributing, should be towards sustainability. That is what is designated by United Nations also. So UN, if you just type Google United Nations Sustainable Development Goals, so whatever process we are doing should be towards the sustainability. And also Dell uses customized products. Dell uses automated systems to offer customized products, reducing unsold inventory and minimizing waste. A very classic example is your mobile phones, your laptops. A classic example is mobile phones. Mobile phones, you have many models coming up day by day. But this was not the case during, say, for example, some 15 years or 20 years before. This has been this has been realized just by the smart manufacturing, where AI is integrated into the process. When you integrate AI into the process, you can optimize. Bigger data sets can be optimized. So Dell uses the data from the customers to optimize to get what each and every segment of the customer wants. So by that, you can have more amount of customized products, and thereby you can reduce the unsold inventory. So unsold inventory is another indicator of not sustainable practices. So to ensure that you have sustainable practices, whatever inventory you are having, it should be acceptable by the consumers. So this is another example of how AI is helping the sustainable practices. I'm coming to the next one. How 3D printing, yes, this is what I told you. 3D printing uses precise material usage. It uses additive manufacturing, that is, it actually increases layer by layer so that it completely eliminates the disadvantages of subtractive manufacturing. But I'm not saying that subtractive manufacturing is not having its application now. Even your traditional manufacturing processes are having their own applications, their own data. Say for example, you have the machining data of a stainless steel. You have minimum 50 to 60 years of data is available, but that cannot be replaced in a single day by this industry 4.0 or this additive manufacturing. But the conventional manufacturing data, when you can integrate with your AI, that is artificial intelligence, you can have better results towards sustainability. So 3D printing, it uses precise amount of material. It produces complex shapes so that it reduces the environmental impact. And any customization, any tailored products also will improvise the sales of the product, just as I told you in the case of mobile phones. Customized mobiles, there will be more sales. In standard mobile phones, more amount of inventory maybe cannot be sold, which is not good for the environment. Some case studies in 3D printing, even nowadays people have started printing their homes. So Icon is a construction technology company which uses 3D printing to build homes so that you can minimize the material usage and you can customize the homes in a better manner. India's first 3D printed post office is already existing in Bangalore. It is called the Halasuru Post Office. So you can Google it, you will be able to see that 3D printed post office. Again, by using this, the construction materials can be saved, the amount of wastage in terms of construction materials also can be reduced. And even IIT Madras also have, as a part of their pilot project, they have printed a 3D printed house in their own campus. I think the entire cost of the house itself is somewhere around 5 lakhs. It is a double-story building, and we are getting it for 5 to 7 lakhs. It's more work. So that is the advantage of 3D printing. And again, another very common example nowadays is the 3D printing of medical devices, especially the prosthetics and implants, which people are implanting in the human body. So each and every human is unique in nature, and standard prosthetics may not serve the purpose. So each and every body shape will be varying, each and every requirement for the prosthetic and implant will be varying. So this can be achieved. This can be optimized by means of 3D printing. Sustainable product development. So you can see, as I told you in some earlier slide, nowadays the space units, NASA has started using 3D printing to create spare parts for spacecraft. So there is a level of usage of 3D printing. Even our own ISRO has started to, if you just look at the response schemes, I think most of you are faculty members from institutes. You might be knowing about the response scheme. So ISRO response scheme actually calls for project proposals for the problems they have defined. So every year in December, they release a list of problems so that people from various industries, institutes can submit the proposal to provide solutions to the problems. And nowadays, if you see the respond projects, more amount of 3D project based on 3D printing are being listed out. So that also shows that our space agency ISRO is also coming up with an intention to produce 3D printed products for their spacecraft. And robotic and automation in manufacturing, as I told you, when you have assembly line controlled by the robots, human errors are minimized. And when you minimize the human errors, automatically the energy efficiency, the production optimization is achieved. So, for example, Tesla and BMW, they use robotics in their assembly lines. And of course, we also have been using, many of our manufacturers also have been using, like Maruti, Tata, Mahindra, they are using. But how the data is processed, that's what is the difference. And nowadays, even our people have also started using this type of assembly lines by integrating artificial intelligence data, big data analytics, artificial intelligence in the processing the assembly line data also. And consumer electronics, Samsung and Apple use robots for assembly and testing. You know, Samsung and Apple, they produce millions of electronic products. And to produce the millions of electronic products in a precise manner, only a robot can do it in an efficient manner. Because you also know, we are also aware of the size of the product. So all our miniature components, and to handle those miniature components, when you don't have a robot, it's very difficult. And when you do it manually, the process efficiency is going to come down. So these are some of the examples where robotics and automation are used in manufacturing to increase precision and waste reduction. And once you decrease waste reduction, automatically you're contributing towards sustainability. Finally coming to the last part, the supply chain and blockchain. As I told you, I'm not much of an expert in blockchain since basically I'm a manufacturing engineer. So blockchain is nothing but they are used in. So before going to blockchain, we will see what is a supply chain. So supply chain is it's a very challenging area, particularly for the manufacturers, because the manufacturer has to produce the components based on consumer demand. And if the consumer demand is forecasted with some error, say for example, a manufacturer will manufacture 1,000 components and one dealer will be having 100 components. The demand for the dealer itself is 10 components. The remaining 90 components is going to remain as an unsold inventory, which is a very big which will create a very big financial impact on the manufacturer's side. Also, whatever the material used for manufacturing also contribute towards the negative impact, negative footprint of the sustainability. So to understand that supply chain, people started using the big data analytics. What is the data? Based on the data, what is the demand? And only based on the demand, they start producing components. The supply chain is a network that connects raw material suppliers, manufacturers, distributors, retailers, which is the ultimate aim is to deliver the products in time to the customers. So before manufacturers and after manufacturers, that's how supply chain is defined. So they are the four major components: suppliers, manufacturers, distributors, and retailers. So what is the key challenge in supply chain? Key challenge is tracking sustainability. So if you see sustainability at various stages, it's very difficult to understand what type of products is required, what is the quantity required. So that is very difficult to understand in the supply chain. Also ethical sourcing, because nowadays if you see most of the companies are focused on the sourcing of materials and how these materials are being sourced. Say for example, I'm using maybe a leather manufacturer. So I need to procure leather from certain suppliers, the raw material suppliers, and I should ensure that whatever leather I'm producing is following the environmental norms of that particular country. So if some unethical practices are there in certain some raw material suppliers, so that has to be ensured. And this can be ensured only by blockchain technology. So that's why blockchain is a major component in supply chain technology nowadays. So blockchain is a decentralized distributed ledger technology that ensures data integrity by recording transactions across multiple computers. As I told you earlier, the blockchain it authenticates the users. So blockchain it ensures transparency. So whatever data given by the any member of supply chain, it has to be transferred. So it authenticates the users and it ensures transparency. Like authenticating users, as I told you, it gives you some criteria. So only when you satisfy all the criteria, your data will be accepted. Similar to your CAPTCHA code and your robotic authentication websites, the normal websites we are using. So sustainability impact is another goal of blockchain. Traceability of raw materials. This is what I told you. Each and every raw material that is being sourced should be within the approved legislations of the country. And these are some of the examples where blockchain will try to identify whether whatever the data is given are authentic in nature. And traceability of raw materials. Some examples are, you can see fashion companies like Patagonia use blockchains to trace the origin of fabrics and materials. Walmart uses blockchain to track food products from farm to store, ensuring they meet sustainability and safety standards. Electronic brands like Fairphone use blockchain to trace ethical sourcing of minerals, how minerals are sourced, whether they are sourced based on all proper regulatory requirements. So this is an example for supply chain and blockchain usage. So in general, these are some of the examples. So I think I'm close to 8 o'clock now. So I think I should be stopping it. So these are some of the examples. Supply chain, you can see DHL, Alibaba, LVMH, FedEx, Unilever, Amazon, IBM. So all these supply chain blockchain technologies are already utilized by some of these mass consumer product suppliers and dealers. And case studies, you can also check with Tesla's gigafactories, how they already Tesla has started to use renewable energy integration and automated manufacturing in their system, and also environmental commitment. So Tesla scales up EV and battery production, again by prioritizing sustainable sourcing, recycling, and energy efficiency. So these are some of the commitments, some of the Tesla is how they are working on. You can just explore this Tesla Gigafactory example. It's a case study. And future innovations and expected developments, emerging technologies like advanced AI, quantum computing, clean hydrogen are part of the sustainability, which will be in the near future. They are the emerging technologies. And the Industry 4.0 is all is actively towards the sustainability, improving the sustainability. And challenging in adopting Industry 4.0 is you need to have high cost. You see all these technologies requires high cost and major infrastructure challenges. It's a very big challenge, particularly in our country. And data security concerns, again, how the cyber security, all other protocols works. That's another major challenge. And skill gaps. So when we want to upskill our workers, again, how our workers will be using these data, primarily the data sets which is generated in the process. These are all some of the challenges which I expect in the Industry 4.0 when we adopt Industry 4.0 for sustainability. So in conclusion, I would say that Industry 4.0 technologies such as IoT, AI, big data, blockchain, and automation are reshaping industries for sustainability. They are the building blocks of Industry 4.0, and we are approaching towards sustainability. And by optimizing these energy resources, we'll be able to achieve circular economy. That's a very important understanding you should have in the circular economy. And we should also encourage businesses to embrace Industry 4.0. So our challenge is to bring Industry 4.0 by reducing the cost, by making it more understandable to the users. So that as an academicians, we have a aspect in doing that, bringing these Industry 4.0 technologies into a very easy form. So that's about the presentation. Any questions or any discussions? I'd like to be part of it. Do you have any questions or discussions? Please go ahead.
So participants have any doubt? Okay. So thank you, sir, for your insight and valuable speech towards this topic. So thank you, Sivaram, sir.
Thank you very much for the opportunity. Sorry for some of the initial, there was some problem with my screen sharing. Sorry if there is some background noise from my side. Sorry for that. But anyway, I thank the opportunity and thank the organizers for giving this opportunity. For sharing some of my understanding on the sustainability. Because I have been working because I'm a part of the Sustainable Manufacturing Lab in my institute, where we have been working towards the sustainability for close to 6 to 7 years now. So we have developed some models, we have developed some data, we have developed some techniques which contributes a little towards the sustainability. That's all how we work in my institute. So if you have any queries, I think I displayed my email address in the beginning. If you have any queries, if you have any collaboration, please let me know. I think one participant has raised a queue. Raise a hand. Sabarish.
Good evening, sir.
Yeah.
Sir, your entire section, they mentioned about the pros and cons only, both the section, theory-based section. Recently you mentioned, now you're mentioning the technicals, sustainability, what are techniques you are using in your academics. I'm asking I'm asking about the section only theory part is only based on the. So I'm asking about the technical substance I need about that.
Yeah, if you see that what I have discussed so far is general overview of the Industry 4.0, and if you come to if you take my work, I am more towards developing chemicals or developing fluids which are used in certain industrial applications as lubricants which are used in to reduce wear in certain applications. So I am trying to develop some green lubricants based on some naturally available sources, avoiding the petroleum-based lubricants, avoiding your synthetic lubricants where they have considerable amount of toxicity present in that. So that is one of the work which I am focused on. So you can take a chemical, you can assess the biodegradability, you can assess the toxicity of those chemicals by our own engineering way, and that again contribute to the sustainability. And in another work, we are trying to develop some materials from biological sources, like which are used for energy storage. Like you would have heard about the phase change materials, which releases energy upon changing the phase, which stores energy and which releases energy upon changing the phase. So that is another area we are working for storing the thermal energy, where it can be used for building some materials. It can be used in materials, particularly in developing building comfort. Even one of my colleagues is working on developing phase change materials which can be kept inside the porotherm bricks, so that the thermal comfort of the buildings are increased. So that once you increase the thermal comfort inside the building, you will be reducing the usage of electricity, you will be reducing the usage of air conditioning. So obviously it is going to be contributing towards the sustainability. And in one another work, one of my colleagues is working on the atomization aspect for when you develop materials for 3D printing. Say for example, 3D printing requires some small powders of metals, so that it can be melted and printed. And one of my colleagues is working to optimize the process parameters so that you get fine powders or fine form of powders, so that when you are melting such fine form of powders, again energy consumption is reduced. So this is another example from where in my institute people are working. So these are some of the examples, and even one of my a civil engineering professor is working on developing fibers for textile clothing. So he develops fibers from natural sources, so that you feel thermal comfort is enhanced when you wear such type of clothes. So these are some of the examples I would like to share. But I'm primarily focused on machining, the metal cutting operation, which you all know, and how to increase or how to reduce the overall energy that is being reduced in the metal cutting operation, particularly for certain type of materials which are hard to machine. But today's session, as I told you in the beginning, I just covered what are all the brief technology that are available, or what are the basic technology that is available for the Industry 4.0. I hope I answered your question.
Thank you, sir. What type of your tooling is using, sir, for this process?
What type of tool in the sense?
Example, you are analyzing the material FEA component analysis, handsaw or hypermesh.
No,
you are using what type of tool implementing?
No, I'm not into computational part. We are actually developing the chemicals in real time. We test the chemicals based on the industrial standards. So I'm not into the computational part. But whereas one of my colleagues is using the digital twin technology, there is a separate platform now. It has been developed by ANSYS itself for digital twins. And in terms of solid modeling, people use CATIA, people use SolidWorks, And in our institute, we also use Mech. And for analysis purpose, people use ANSYS. And there is also COMSOL is there for using multi-physics problems. COMSOL is used. And for vehicle dynamic problems, even MATLAB also helps for simulating certain vehicle dynamic situations. So it depends on the hypermesh is also used, particularly for meshing certain geometry. Even as a part of sustainable manufacturing, I used one of my scholars used ANSYS Fluent for understanding the fluid behavior when when the fluid is converted from a normal liquid form to a mist form, how the behavior understood. It's like a two-phase flow. So it's like a liquid flow and gas flow. So Fluent also helps. So these are some of the examples.
Okay, sir. Thank you. Thank you for your introduction.
Thank you.
Thank you, sir. Sivaram, sir, for your valuable moment. Share with us.
Thank you, Professor Prabhu. Thank you. Thank you for the opportunity.
Okay, next section. On this momentous occasion, I would like to invite our second section chief guest, Mr. Rajkumar, Sengodan, Kannaiyan, Project Manager, Global Customer Projects, Danfoss, Denmark. Despite being very scheduled, he has given considered for our FDP. Once again, I welcome you, sir. I will hand over.
Hi, everybody. I just want to ask you, how is the noise? Is it too noisy? Because I'm right now sitting in a public space, so there should be some kind of noise, or is he able to hear some in a proper way? How is it? And
there will be no.
Can you hear me?
No noise.
There's more noise?
No, sir.
Okay, my voice is clear?
Yeah, sir. Voice is clear.
Fantastic. So let me share the screen. How do I do it?
So in your desktop, there is a.
Yeah, I can see that.
Now
yeah, I can see the entire screen. I'll share my entire screen. Yes. I'm sharing my screen. Is it okay?
So not visible, sir. Right now it's visible, sir.
Great. All right. First of all, thank you for inviting me. I thank the professors and the management for inviting me to present about the future of the smart manufacturing. And it's wonderful to speak to you all. My name is Rajkumar. I'm a project manager for the Global Customer Project Management, working for the Danfoss, and I'm living in Denmark. First of all, I want to thank also the previous speaker, Mr. Sivaram, who covered almost all the points what I'm supposed to talk, which is going to be a little bit easy for me to go ahead faster as well. So I'm going to take roughly around like 45 minutes to 50 minutes, because most of the points will be almost like a repeat of them. Let's get started. And if anybody wants to stop in between, you can just raise the hand, or you can switch on the mic, and then you can just keep talking. So no problem. We can stop in between and answer. We do not wait for the last moment and cover up the points. All right, let's get started. So first of all, I'm going to talk about the future of the smart future of the industrial revolutions, or the current and the future. I would say that, how it happens today, and it's going to be the future smart manufacturing. I'm going to walk you through some of the points, which is right now you can see on the screen. And let's get to the first point of the fourth industrial revolution, is what we talk about, or even some people call it the fifth revolution. So the current revolutions, what we see here for the future, for the current and the future, we are talking about the cyber physical system, which means the integrations of everything that helps to improve the smart manufacturing system. That's the biggest one what we see here right now. So there are several details that we need to touch about the smart manufacturing. We need to understand this a little bit. So before going into that, what is the smart manufacturing? I'm going to walk you through some of the, before going through the very clear, solid points, I'm going to walk you through the general points, which is covered already by the previous speaker. So it's going to be more of a repetitive session. So the Industry 4, or the fourth industrial revolution, refers to the fusion of digital, biological, and physical systems. There's contributions on every direction what human can capable of providing information, the vital information to keep this industry to be very, very smart. So what is smart manufacturing? So how do you get to this smart manufacturing name? So what is really smart manufacturing? The smart manufacturing. So if you want to do some smart manufacturing, you pen down something in a paper and then you start thinking something about how the product has to be, how it has to form a physical shape when you manufacture, how this the idea of thinking process can be generated as a physical product in the end of the process. So this is the traditional waterfall methodology, where you start something to think about it and you pin down on a paper, and then you make some kind of prototypes, and then you test it, and then you go for some verifications, and then you improve your prototype verifications again, and then you go for the manufacturing. This is the traditional way of doing it. Today, it has gone into different directions. Basically, we are trying to gather more automated knowledge from the realistic world and then analyze more about what about this data, what is telling in the realistic world, and then combine with the efficiency of the robots, what we know, and with enhanced technology, that's the artificial intelligence. Providing these together, it gives us a very, very, very strong manufacturing setup. So this smart manufacturing, what is the goal of the smart manufacturing is to provide a product which satisfy the need of a customer. The demand is very strong on the field. You take any product, you name it, any product. Let's I think the previous speakers all touched about a little bit on Tesla product as well. So you talk about the Tesla product, and Tesla is really one of the strong product which keep improving day by day. Every day is completely an improvement what we can see. How do we get this one? They combine everything into one information to go into the smart manufacturing. It's a real-time information they are collecting it to improve the efficiency of the product. That's the ultimate goal. Number 2 goal to get this manufacturing is to reduce the cost. So nothing comes for free. So if you want to improve something, that has to be a cost for it. So we are talking about the smart manufacturing. In a holistic approach, this smart manufacturing has very, very strong impact on the cost. We'll talk about it later, because the cost is not something we are talking about in most of the cases. Improving efficiency, that's the most of the thing we're talking about, and then production optimization, that's what we are talking about. So, sorry. So what are the key technologies that's enabled the smart manufacturing? So today, the key technology, that's the artificial intelligence, the machine learning. So the machine learning and artificial intelligence is one of the key technology that helps us to enable the smart manufacturing. I hope you might know about different robot technologies around the world. You talk Fanuc, you talk many other Siemens robots, a lot of things. One of the best robots I am aware of, which is called Universal Robots. Please go to the Google and then type Universal Robots. I think the company was bought by another company. I don't remember the name of the company, but sorry. So it's called Universal Robot in the past, and you just go on and Google about the Universal Robot. That's one of the best artificial intelligence you can do with that. The coding to operate the robot is very simple. It's very, very, very simple. You just need to hold the head of the robot, move the direction what you want, and that's it. And the system automatically writes the code of what it has to be done. It's a fantastic one. The machine learns by itself. That's one of the biggest one what I see as artificial intelligence getting integrated with the manufacturing setup. So what these robots automations does, the robot automation does is provides a vital support in enabling the quality product. So the quality product is the biggest objective. Right? So the biggest objective is to contribute. One of the contributions is coming from the robots and automations. The robots provide a very precision assembly, a precision process to enable, to avoid zero failure in the products, or I would say close to the zero failure in the products. So that helps us a lot. So how do we get this robotics into the automations, and how do this practically get it done? So big data plays a vital role here. This is one of the key technologies that has to be done. So how this robotics senses these informations on. So within Danfoss, we have some setup where we convert a multiple production operation into one single operation using the robots, including the measurement technology. So I want to jump a little bit to an image what I have here. So this is one of the coordinate measuring machines. So you can see that this is a measuring system that measures the product. the manufacturing products here. You can see there is a small product placed up in this platform, and there is a probe here that's moving around. This is like an hexapod, the inverted hexapod. You got the legs up, and all these legs are moving, and then there is a sensor that moves around to measure the information. This is an online system. So this system collects data of this particular product. For example, if you make a cylinder for a specific diameter of the specific tolerance, this setup measures online about the cylinder with the tolerance of what it has to be and so on, and it provides these data back to the robot system and tell the robot system that, okay, here the dimension is going out of tolerance, or it's going to the maximum of the tolerance. It has to go to the nominal one to have the better production. So this are interlinked. The key technology is like a neural network. Everybody knows about the neural networks, or the neurons in the brains. Every brain's neuron cells is completely intact, which means it's integrated to one another. So providing the vital information to each and every cell to act in really and synchronized and rhythmic way. So this big data and robotics and artificial intelligence are working like a synchronized pattern, which provides an ultimate information for you to succeed the demand and the quality which is needed in the market. This is one of the important things what the smart manufacturing is telling about, and for now and for the future. And there are sub products which plays a vital role here. So sub products you call about 3D printings and Internet of Things. Internet of Things, I would put it as a base, because the internet is connecting everything in place. So internet is one of the vital information that is connecting all the informations to see from one part of the world to the other part of the world, or everybody in the loop who is handling the smart manufacturing can able to see what's happening in this. That's really fantastic. And of course, the byproduct of this is a cloud computing, basically. So you get everything into the cloud, so which means I'm sitting in Denmark and I will be able to see my product, which is somewhere in Aruba Islands, close to the South America, close to the Brazil. There's an island. My product is sitting there. I'm able to look at the data of this product, what's happening on this particular one, what is really happening on my product, which is really functioning very good, or is really good, how is the data looks like. I'm able to see seamlessly without any interruptions. I'm able to see this information very clearly. That's really super great. And these are the key technology enabling the smart manufacturing for the now and for the future. And you can ask, is it everything is interconnected? Yes, it is. Everything is interconnected. So nothing is, you cannot leave any of this one on the field. Of course, maybe you can leave out a little bit on 3D printing, because 3D printing is not something so online that is connecting all this information. But 3D printing is one of the byproducts which enables the product to go really much faster. The 3D printing is really helpful in the innovation. If you talk about innovation, and innovation in the previous way, if you want to make a product, you make a product physically, you do some kind of testing, and then you do it and so on, blah, blah, blah. The 3D printing today, you can make something very fast, look at the product, look and feel, yeah, improve the one, go for it multiple times. In no time, you'll be able to produce a product in hand using a 3D printing technology. There is different kinds of 3D printing technology. I'll not go into much in detail about it, but there is a lot of things that you can do it. And the artificial intelligence helps the 3D printing technology to improve more. If you say, for example, you have a mouse on your hand, you want to make an ergonomics mouse, which is really, the one what I am using is I don't remember what is this, it's Mech Master. What I'm using right now is Mech Master 25. That's the mouse what I'm having right now in my hand. And if I want to optimize it, today the AI technology with the big data information on the field provides the information. So, okay, the shape should be something different. The thumb is not in a proper place on my mouse, has to be in a different position. So the 3D printing can online suggest us to change the shape of the mouse to go forward, to have multiple number of ideas coming up on a physical form on a hand so faster. So that's the one of the 3D printing advantage what I see actually. So these are the key technologies enabling the smart manufacturing for now and for the future. There might be something added in the future, I don't know, but for now, this is what we are seeing right now. And I'm able to see most of the information what we see. And the big data analytics and big data, what I see. Hello? Is any questions? Somebody spoke. All right. I'll go for it. So let me pass to the next slide. What is the role of the IoT in the smart manufacturing system? So basically, the Internet of Things, that's the base platform to connect everything in place. So you talk about anything. So that I placed an image. I found it in Google very fascinating for me to show up here. This is one thing what you talk about. So I'll pull up one information about this IoT, which is everybody using it. I think everybody has a smartphone or a smartwatch on your hand, I guess. So everybody's having this. And then the smartwatch It helps to monitor your blood pressure, your heart rate, and your pulse, basically. So the Apple is the best example. Apple products, the smartwatch is really one of the best one what I see actually. So that provides a vital information to the doctors. That's one of the classic case in US. What happens is that this the smartphone, there was a watch on a man, very old man, and he stumbled on the streets, and because of this pulse rate and this pressure, and it sent an immediate notification to the doctor, and then in no time there was an ambulance came to the spot to pick this person. There are two information that's going up here. One, the location of the person is so dynamic, where is he moving and what is happening and all the stuff. This is one of the vital information to the doctor in the healthcare industry. Number two is personal information, especially the blood pressure rate, the heart rate, and all this stuff is going seamlessly without any interpretation to go to the doctor information, and they're able to monitor this guy. Okay, something wrong with this guy, and we have to go immediately. And it triggers an alarm. It triggers information to the ambulance. Ambulance goes to the spot, pick the person, and then without any trouble, you can see this person is getting saved. It's one of the very, very strong example in the healthcare industry, what I really like about it. So I believe everybody has a smartwatch on your hand, and it's getting more and more advanced on every month. Every month goes by, there are a lot of information that's going up on these technologies. They'll keep improving. The first generation of the watch is not something like that. So you just have only a digital stuff and so on. It goes up and up and up again. So probably there'll be a lot of information coming up in the future on this particular healthcare stuff. That's one of the best one, I would say. And then the IoT on the automation side, especially on the automotive side, I'll talk about a little bit on this Tesla coming up on this further slides. Very, very interesting about that one. I'm going to talk a little bit more on about the Tesla because I'm very. We have seen a lot of Tesla cars, and I don't have one, but I can see some of my friends has it here, and I know how the Tesla getting into this smart manufacturing in the real-time environment. I'm going to talk about it later. So the IoT enables the continuous monitoring of equipment in real-time situations. So, and then if you talk about the industry side, condition monitoring system, that is one of the best one what I do. I'm working in the high pressure pumps. Danfoss has a lot of divisions, and I'm working in a division called Danfoss high pressure pumps, and we are producing pumps from the small scale to the very large one for the reverse osmosis. So we have the pump all over the world, and we have the condition monitoring system sitting up on these pumps, monitoring the pressure, flow, and the vibrations. There are a lot of things getting monitored. I'm sitting at my desk, and I'm able to see how this pump is operating, sitting somewhere in West Indies Islands or somewhere in the southeast, somewhere in the islands and something like that. Very, very fantastic. So this IT bridges my communications or my informations towards the pump, and the pump informations towards me. And in turn, I'm able to provide this information to the innovation department to make sure that the product is running good or something wrong, and I'm able to stop for the predictive maintenance. So one of the biggest things about the industry's product that is out in the market, especially in using the IoT industries, what the help is giving it is the predictive maintenance. You name any product, here on the feed. So for example, these images, what you see, the smartphones or anything else, this IoT tells what to stop for the predictive maintenance. When it has to go for the maintenance, when it has to go for the service, when somebody has to get into this product and to look what is happening and so on, when some parts have to be replaced, all these informations, this is the main communication platform. And there are a lot of struggles right now in the IoT industry. It's keep upgrading every now and then. There is no standards we're talking about on the IoT right now, and it is coming up. It's going to come up. So in turn, one of the downside, what I see is that we are missing a lot of resource, plenty of resource connecting all these industries in the IoT platform. You've got a lot of software professionals all over the world. There are many people all over, but bridging these IoT professionals to all over, we short of resource. This is one of the biggest takeaway I can see that, many of the people are working in these platforms to get the product info. So the IoT plays a major role in the smart manufacturing, dynamically, rhythmically, in synchronized way. Let's go about the artificial intelligence. This is one of the artificial intelligence machine learning is also, I would say, it mimics the human intelligence. So the robots is really mimicking what a human can think. For example, I would call the ERP system. enterprise resource planning system, for example, it's a software tool that we have in a system where the purchase order goes in and the order confirmation goes in and it triggers the data information to the manufacturing setup to make a product, and then the manufacturing unit says, I'm finished this product about this particular date, and it sends the message to the customer the product is finished, all this stuff. This ERP system is one of the biggest one what I see as an artificial intelligence. Completely fantastic. So basically what I do in the previous days, I sit in my computer, I receive a purchase order from my customer, I read the purchase order, and I go myself and creating order confirmation to the customer manually. All these manual informations is prone to error. Being a human, instead of typing I might type O, which is next to the I and O, or very close to in the keyboard. I can make mistakes, but this artificial intelligence doesn't make mistakes. When you make the algorithms in a proper way and you test it properly and it doesn't make any mistakes, probably you will keep improving it day by day, but you don't make mistakes. That's one of the best one what I see coming in this name. So these supply chain productions, everything is grouped under this particular name, the ERP systems, because supply chain is part of this ERP where, supply chain is producing the product and dispatching the product in terms of logistics and all this stuff. But ERP tells information what it has to do, when it has to do, when it has to be sent out, and who is responsible, who has to go to the email, blah, blah, blah. So that's why I see it. And then one of the important things is cobots. Cobots is multiple robots put together. It's a collaboration of the robots. That's called cobots, actually. So it's not one single robot is performing. I would say the best example of this cobots is that you guys are familiar with the sheet metal parts, stamping parts in the mechanical industry. So you have, for example, you have the parts which has to go for transfer pressing. And I would say 10, 15 years before, the transfer pressing were made in one single blocks. Right now, it's not like that. The smaller machines clubbing with the robots, with the multiple robots, and you can reduce the cost, and then these robots takes care of these transfer pressing without having a one big block of metal standing for this continuous operations. It reduces cost, efficiency increases, productivity increases, the precision increases. There's a lot of advantages going upon these cobots. So this is one of the biggest advantages in this AI I'm talking about. And this AI helps a lot better in predictive maintenance. Predictive maintenance, which means that actually, so which I explained before. So it helps us to tell when it has to go for service, when it has to be stopped, when it has human intervention to take place, and all this stuff. So it's very, 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 very authentic information. It's not like human to human, because when I say, okay, this product has to be serviced in 12 months, I can tell that. But the AI data tells no, it has to go a service for 6 months. How? It has the data from the machine. It tells that it has operated for about 10,000 hours. Now at the 10,000 hours, this product has to go for service. A robot arm, for example, you have an arm, you have a servo motor on the arm. If the arm is rotating constantly for more than 10,000 hours, the system should trigger that this arm has to go for the service, and you got to replace something else there. It's a fantastic one. So this AI is really, really getting improved, and AI is new one in the market. It's getting more popular in the market. It's not new one. I've seen the Asimo robots in 2005 in the Honda industry. Honda has this one of the artificial intelligence humanoid robot that's developed far before, I would say in 20 years before, in 2002 or something like that, the Asimo robot. You can just Google it. There's some pictures coming up at the latest slides. You can see that actually. They have this Asimo robot, very, very self-intelligent robot. And they predicted, Honda predicted that the artificial intelligence is going to take over the world well ahead. And they built this robot and to test it. They tested these robots in a long way back. And they are more advanced in terms of technology. They're implementing in all directions in the industry. So this machine learning and artificial intelligence should go hand in hand in order to have a very success in the smart manufacturing. Let's go over to the next one, robotics. So here, you can see there is an Asimo robot standing. This is a humanoid robot. So the humanoid robots have been first initially made to perform some of the tasks where the human cannot intervene. One of the best examples is, the nuclear industry. The nuclear industry is a very, very, I would say, a very dangerous environment if something goes wrong. If something goes wrong, everything will be really in a toss. So they are trying to use these kind of smart robots in this place. And on the left side, you can see there is an image where there's a sequential of robots. And one of the best examples of the sequential robots is this spot welding, which happens in the car manufacturing industry. There will be multiple sheet metals put together to spot welded to make a frame of the cars, right? So this is a very sequential. And this is a repetitive and a very high accuracy environment that happens. So the robots are highly efficient here. We cannot put 100 humans to stay there to make the welding or something like that. It's impossible to have the repeatability with any human placements. Robots has a very, very high, strong repeatability. You teach them to make one particular spot welding at this particular point, it repeats n number of times until something wrong in this particular product itself. For example, the predictive maintenance has not been done, then something goes wrong. So all these, what I said before, the 4 points, everything has to go in hand on hand in order to have a successful smart manufacturing. Let's go to the next one. It's big data. So the big data, what is big data? So we're talking about the data and stuff. So there is some process to understand how this big data. So the main information of big data is the collection of the data. That's the first step. The collection of this data, and then visualization of this data. We need to visualize the data. And number two, and what's this one? Analyze the data, transformation, and storage and management of this data. These are the 5 important stuff in the big data. So how these data are collected? So we get plenty of softwares which is coming in emerging market. For example, the one what I said right now, this is a CMM measurement machine. This measurement machine gives us the information to the robots collecting the information about the dimensions of the particular part, so that everything is good or bad, or is moving away from the tolerance, or moving really in the lower or higher end. It provides information directly to the informations in the loop, and then the robots corrects the manufacturing about this particular product. So there is a software that is integrated between the robots and this CMM measurement machine. That's the collection. So it visualizes the collected information, it analyzes whether this is right, it transforms the information to the robots to make the proper product in a really good dimension as it has to be. And this data is stored somewhere. So which means every time when there's something goes wrong, this stored data is being pulled back, and then it's been used again saying that this is exactly wrong, this is exactly right, and it has to set up properly. And this is the whole big data we're talking about. Collection, visualization, analyze, transformation, storage, and management. Yeah. And this big data is used in all industries. We can talk about it. So the very common one which I'm always puzzled and I'm really always think about it. So you go into any airline website and then you start typing your start and the destination, and then you're pulling up the price of your destination. So in 1 hour, if you just go ahead and then same destination, same information, your price changes within 1 hour. I have faced this one. So basically the airline industry analyze your information, how frequent you are doing it, how many people are using the same location, start and end destination, how the price can be adjusted between number of people and all this stuff. It analyze and provide you the best information. Sometimes can go worst also. So based on what we are looking at. So this is a big data, the analytics in the manufacturing and analytics in the real-time world where we see. So in the manufacturing, there are a lot of examples what I can code in the big data. So that one I will not tell here because I'll go to this slide number, an example, slide number 11, where I'm going to tell about the Tesla, where we are seeing some real-time information. Let's jump onto the 3D printing technology. So 15, 20 years before, the 3D printing technology is somewhere non-reachable for any, I would say, common users. Today, if you place 25,000 Indian rupee, you'll be able to buy a 3D printing machine, which is like 15 centimeter by 15 centimeter cube. The flow platform, you will be able to get a 3D printer. It's a very cheap one, you can get it. So it is reachable for everybody. So what it does, it creates your digital information into physical information for you to look and feel and to improve the products completely in no time. So what is it doing? Okay, so what am I improving? So the improvement is directly related to the demand and supply. Demand from the market always tells us, okay, it has to be improved because the customer needs something to be improved. So the time to response should be very shorter. So there'll be no patience on the market, because there are 100 competitors on the market to produce a designated product. If you are not able to provide, or if you're not able, the innovation department, if your company is not able to do it in a shorter durations, then you will lose out of the market. So you cannot win, the ultimate goal. So it reduces the time. Time is money. Money is time in the industry, and it also reduces the cost for implementing an innovative product. It's a very fantastic one. Cost is time and time is money. So as I said, it's all related to this particular point. So this 3D printing technology is now reachable for everybody. Anybody can do it. Even even a very small scale industry can be able to afford this kind of products in order to create a very smart manufacturing. This is not directly linked to the smart manufacturing, but it is linked to the smart innovation. The innovation is part of the smart manufacturing. So this is linked directly to the innovation of smart manufacturing. Right. Let's go to the next one, benefits of smart manufacturing. So the benefits, I'm keeping about the increased efficiencies. So how do we keep increasing the efficiency of the product? So every time when something is getting produced, so you always miss something because there's always prone to some kind of error. So smart manufacturing will tell this enabling to increase efficiency to go up and what is missing, first of all. When you have a pump on getting tested and if the efficiency lower, the system will tell you the efficiency lower. The efficiency lower can predict which particular product is out of the quality and which has to be improved. You can really predict this information. It does increase the efficiency of the product. Efficiency doesn't mean only the efficiency of the pump. The efficiency talks about everything in holistic perspective. So when you improve efficiency, once the next particular is getting improved, it improves the quality of your product. So everybody writes the quality of the product. Everybody likes quality products. Nobody is going to buy a lesser quality, right? So everybody needs a quality, and it's really important. Cost saving. So when you have a product with an increased efficiency, improved quality, and cost saving, that's one of the things what we are talking about. Hold on a second, please. Yeah. So cost saving. So as a manufacturer, I cannot create a product which has a very, very high cost. I cannot go into the market and sustain myself, putting up myself as a number one if we don't have a proper cost. So these information together help me to save the cost. Customization, that's another big topic of the smart manufacturing. I can go into particular section of the manufacturing unit and tell this particular one I want to customize it. I have a whole lot of automation productions going up. If you have, for example, make a cylinder in super duplex stainless steel material. There's a lot of materials, and we are operating materials called super duplex stainless steel, which is one of the top grade material right now in the industry. So I can go and customize what I want exactly on one particular operations. For example, I have a thread, I have a hole, I have a through hole, I have a semi hole, I have a chamfer, I have a counter bore, all this stuff. I can go and specifically customize what I want using the smart manufacturing technology. So it helps me to take a better decision. It tells me don't go in this particular RPM to bore or drill a hole at 800 RPM. Don't go. Just go with the 500 RPM. That's enough. Why? Because it saves it saves the operation time. It saves the operation time in turn saves my electrical bill, example, and so on. You can add much more. So it helps me to make a better decision, sustainable decision. I can repeat the decision and it can be more and more accurate. It's very sustainable. So these 6 points are one of the major benefits of the smart manufacturing system, which is moving from now and going up forward in the coming era. Yeah, this is very, very nice. Let's go to the next one. Challenges of implementing the smart manufacturing. So what the challenges we are talking about? And one of the biggest challenges is investment. The smart manufacturing is not so easy to implement. So we have to look at the industry, what we are talking about, how this can be implemented, and it comes at what cost. So if I make this industry into a smart manufacturing system, what is the return of investment? And it is not easy. So we have to really balance that. Legacy systems. We already have the industry running up right now. So you name any industry, everything is more or less, I would say 75% of the industry is running in a legacy system. Converting a legacy system to move forward with the smart manufacturing is not such easy technique. It can be done, but we are missing skilled folks to do it. A lot of skilled folks is missing to convert this legacy system. We have a lot of industry getting struggled on this very particular one to convert this legacy. That's important. And one of the dangerous part we are touching is the data security. When everything goes up into the cloud, everything goes into the IoT system, data security is a really big question mark. Everybody has a smartphone in your hand, and we think that it is a very safe one. No, it's not safe. The data security is getting updated every day, every minute, all over the world. So one small loophole by the hackers can go everything wrong. We have seen in real time a lot of worlds, right? So people get hack your credit card and so on. I myself a victim of a credit card hack. Recently, I was in India in summer, in July, before my vacation. My credit card was hacked. I didn't know that, right? So data security is one of the biggest things. So now you are putting the smart manufacturing in the entire system of your manufacturing industry into this particular platform, which goes up in online, and this online is prone for the theft of your information. So data security is one of the prime one. It's one of the key challenge, biggest one in the entire smart manufacturing system. Skilled workforce, I think I touched a lot of particular point on the skilled workforce. In complexity, I'll come to the complexity because this is not an easy one. It's a complex, really a complex one. We cannot simply club very, very simple operation into this smart manufacturing, where there is really a complex one can reduce the cost, improve the quality, improve the efficiency. We have to put all these into one single bucket and then see, okay, this efficiency is really improving. Yes, this is exactly what we want. You need to look at it. The complexity versus the balance is really important. Standardization, right now we don't have any standards to do it. And I have something else and I say it's my standard, and there is no kind of standard that we are seeing in the market right now. This smart manufacturing probably come in 5 to 10 years from now. So these are the challenges what we see. What is giving us, so the young engineers today who are doing the engineering and who are just out of the engineering into the field, they can think about it, and we never know. Somebody can invent something, and this particular one can be a really smart to go up, starting up an entrepreneurship. Yep. Hello. Is somebody talking? Prabhu, can you hear me?
Yes, sir.
Okay, I can go ahead. All right.
Bunnyvel sir, please mute your mic.
Okay, great. And now I want to go one of the artistic company, Tesla. So there's a background noise. All right, good. Why I picked Tesla, for example? I'm going to quote only one example because I think my previous speaker has quoted a lot of examples. I'm going to talk a little bit, at least for 5 minutes, about the Tesla. Tesla is not selling the car. It is selling a real-time environment to a user. So the Tesla is collecting the data. Basically, if you have a Tesla, and Tesla can also drive automatically on the street. I think you know it. I think you heard of it, and that's pretty much soon. There's going to be a lot of Tesla in Indian environment as well. I'm sure on that in the near future. So the Tesla is not only selling the car; it is selling, or it is providing a vital information for the user. There are cameras all around the car which collects the information. It analyzes the information. It transforms and visualizes. That provides information to the smart manufacturing, which means they are improving every day, every minute. If you have the Tesla car on the road, and there are like at least 8 cameras all around Tesla, we can provide information to the system telling that, okay, there is a human standing on the way, there is a dog coming up, there is a car coming up, there is somebody overtaking it, and you're on a wrong lane, and you are going too fast. You can tell every information. What is it providing information to the manufacturer of the Tesla in the industry? It provides you the real-time information, how fast you are going. So it can tell the Tesla manufacturers, there's a lot of people who are going so fast, and you need to restrict the fastness because the safety is the biggest concern today on the traffic environment. So it restricts the speed, and people are on the phone, talking to the phone. Tesla will never allow a person to have a phone talking and driving together. It sends signal immediately to the manufacturing information saying that you will get blocked. You will really get blocked. Absolutely. So that helps us to be more safe. Accurate, precision information on the road. It's getting better and better. You can really imagine you have a self-driving Tesla on the road, and then somebody goes really fast in front of you, or somebody is crossing in front of you. Tesla can stop within no time. Of course, it's not the best one, but I can tell you they are really very close to say the best one. And all Tesla models are completely on this one. So they are acquiring the data real time on the field and improvising and everything. And one of the good thing about the Tesla, or I would say Volvo, which had it many years ago, and it's one of the best one what I see actually. This is based on the IoT, on the real-time environment. The Tesla had, the Volvo had, you can set based on app. You can set tomorrow morning 6 o'clock. I'm going to wake up. So we are living in Europe. I'm living in Europe, and the climate is very cold, especially in the winter. We are going with zero and sub-zero, which means I want to set in the app. I say, Volvo, please set my room temperature inside Volvo car at 23 degree at 6 o'clock in the morning. I'm going to drive to my office at 6 o'clock. And then the engine will start at before 6 o'clock, and then set my air temperature inside my car at 23 degree and put the heat on my windshield and remove all my ice on the screen, and everything will be goes off. And I get at 6 o'clock into the car. It's a warm car inside. It's a fantastic one. And Tesla has that as well, but Volvo had it much earlier before Tesla. And Tesla is well known because they have much more intelligent technology coming in place. So it has it. So this is smart. It collects information, and then over the period of time, the Tesla will also help you to visualize the information, saying that, okay, this particular driver gets at 6 o'clock, we will get ready, which means you don't need to go in a very cold weather at -5 into the car and say it's so freezing inside, and then it's still the ice on the screen. You have to wait for another 15 minutes to clean it up. No, it's not like that. So it provides a vital upgradation for the user to be on the better side. So now, not only Tesla, there's a lot of Chinese companies that are coming in place. There's a lot of car companies right now in the market, which is getting very close or in par with the Tesla industries. And not only Tesla, I can also say Mercedes. Mercedes coming with the price tag. I would say that Mercedes is like, yeah, it's in a premium scale, and there are a lot of equivalent product with a better efficiency, which is coming in a lower price range, which is reachable for everybody. Is connected direct to the smart manufacturing industry. It collects information. I'm repeating again. It collects, analyze, transform, visualized, and this visualization goes into the smart manufacturing and into the products day by day, every day, every time. These cars are controlled by software, controlled by IoTs. So I can buy a standard model of the Tesla without any software, and I can after 6 months I can go back and test. I want a software drive automatically. They can put the software, and then the car goes automatically without any driver. It can go self-drive. They can do it. So it's the very, very strong example what I'm providing, and this can be applicable also in the healthcare industry and anywhere. This one example, you can just think about anything else. What I said example before, as having a smart watch on your hand triggers an information to the doctor telling about my pressure, my flow rate, and blah blah blah. Everything is seamless connected. So this is a smart manufacturing what I call it. And I told an example about the production, or example of the output of the real time where the people are getting used, but there's a lot of things happening behind the scene. But the data collection is the vital information that every company is taking from everybody. And it's also danger, I would say. Let's get to the trends to watch, the future of the manufacturing. The trend to watch, I would say, these AI-driven factories getting it. There's a lot of things getting up, especially in the AI algorithms. I think we know more about this algorithm information. So you don't need to go into deep, but there's a lot of things getting up. This is one of the trends to be watched. Sustainable manufacturing, more focus on reducing the waste management, energy efficiency, carbon footprint reduction. That's one of the key ones what I will see actually. Decentralized production. So manufacturing takes place closer to the consumer, reducing the supply chain complexities and costs. So, this is one of the things we have to keep watch for the future. Sustainability and smart manufacturing, there are three important factors, three important points: efficiency, waste reductions, and eco-friendly production. These are the three important points for sustainability and the smart manufacturing. And I would say the smart manufacturing global supply chain is integrated part of this system, especially monitoring the real time, avoiding the risk, and improving the logistics to meet the demand and supply where the product reaches to the end user in no time. So these are integrated part of the system. I see that too. Yeah, let's go to the next one, cybersecurity. So this cybersecurity is one of the biggest I would say consequences that we have to keep in mind, because securing the network, data protection, and monitoring systems is three important factors what is to be improved every day, day by day, every second. If there is an industry that is working completely with the smart manufacturing I strongly believe there is definitely a group of intelligent people sitting behind controlling the cybersecurity. It can go up in any directions. If I have a Tesla car that is self-driving and if it's getting hacked, who knows? I may not end up in the same direction what I want to go. So I'll be in the wrong directions what I'm not supposed to go. So a lot of things is happening right now. And likewise, if I have a smart manufacturing, continuous robot system in the production line, and suppose if I lose something on the security, it can go completely crazy wrong. So these things are very, very important to keep it in mind, and it has to be improved every day, day by day. And there's a very, very high potential markets for the now and the future. There are a lot of things coming up on this particular topic. Yep. And the next one, preparing for the future smarts. How do we prepare investments in technology? That's one of the biggest questions. And what level of investment we want, and what has to be adopted, what is needed level, how I can customize and moving forward on this particular smart manufacturing. That's one of the key one, what I see actually. Training, we need a lot of employees to get trained, upgrade the skills from the legacy system, moving forward for the new environments. Innovation doesn't stop with one particular line, one particular statement. It is a complete ongoing process forever and ever and ever. So innovation starts today, it never ends. So we have to continuously evolve with new improvements to keep our product going. So this is smart manufacturing, what we need to look up for the future. I would like to conclude by saying that the smart manufacturing is, for now and for the future, is going to be much more complex, and the complexity will definitely get reduced, which means the demand versus supply will get in a very, very demandable rate for the user, from the consumable product to the engineering product, the healthcare industry, to the all over the reachable things that human needs, including the humanoid robots. All right, and that's my conclusions about the smart manufacturing. Let's go into some question more.
Participants have any doubt? Can you ask?
Any questions, anybody? Please raise it up. We can have a talk. Any question from anybody? There's a deep silence. Either you understood everything or you didn't get me. Thank you so much. I think it's. Thank you, professors and the management. I really appreciate that you're reaching out to me to participate in this conference, and I believe my presentation would be, even though a few of the points is repeated from the previous speaker, probably it could be useful and something knowledgeable getting into you, I guess so. And I really thank you everybody once again, and if no more questions or anything else, I would say thank you so much. Thank you for your time. Have a great day.
Thank you, sir, for your insight and valuable speech.
Thank you, Mr.Prabhu. Thank you so much.
Thank you, sir.
All right. Have a great day. Bye-bye. Bye.
Bye-bye. Participant, so today's feedback has been sent to your chat box. So participants, please fill the Google form. This will be considered as today's utterance.
So the attendance link is not working, sir.
Sir, if anybody facing issue in enter into the Google Form,
Yes, sir.
the link is now working.
No, sir. Actually, when I was open it, uh, they are saying it redirection notice. The page you were not in prior to send your message. Yes, sir. It's working now. Thank you.
Okay, sir. Now you can enter your feedback.
Okay, sir.
Thank you. Thank you. Okay, today's session is over. So participant can do the Google Meet.